Hi, everybody. I'm Jen. This is John. We're a bit of a double act these days. John and I are part of the public sector, police and law enforcement team together. We've spent the better part of the last 2 years working really closely with some partners in the police in the UK, working on some pretty interesting applications, one of which we're gonna take you through today. Also, we're especially lucky that we also have the lead developer who wrote all the code for these applications sitting in the back of the room. So if you want to ask any really tricky technical questions when we get to it, please feel free to make life difficult for him. Please sit down. I'll give everybody a second. Wow. Originally, I thought Steve Ingram was going to be our only attendee. I thought that was it, just because he's a mate. But apparently. Please sit in the front, heckle, throw things. All right, going to get started. Going to talk to you today about, going to try to accomplish a couple of things today. What we want to talk to you about is this incredible project we've worked on with the police, but we also want to do a technical deep dive into MarkLogic as a multi-model database. If you've been to MarkLogic in the last few years, you might have been unlucky enough to have seen me speak. And I would have talked about semantics, and I would have talked about how triples are great and they're the most magical thing ever. But what we want to talk about this year, and I think Gary and David touched on this in their keynotes, about the multi-model database and the power of the combination of documents and triples. The nature of policing is changing. It's radically changing. You don't have to be inside the police and law enforcement community to understand that the nature of crime is changing. This quote here, I don't know if you can see it in the back, so I'll read it out. The increasing availability of information and new technologies offers us huge potential to improve how we protect the public. But it also sets new expectations about the services we provide. This is the National Police Chief Constable's Vision 2025 paper where they set out their goals for policing. But the truth of the matter is that the nature of crime is changing, the nature of police goals are changing, but unfortunately IT is not keeping up with these changing demands. The police in the United Kingdom especially, but also elsewhere in Europe and in America as well, have shifting goals. It's not just about having bobbies on the beat anymore. It's not just about making sure that people aren't breaking into cars or stealing stuff from your home. Police would really like to be able to move to a proactive model, and that's not really your minority report, pre-crime idea, but it's the idea of being able to anticipate low levels of crime before they escalate into something harmful. It's the ability to intervene in somebody's life before they have serious harm. It is the ability to try to reduce crime before it happened, rather than just pick up the pieces after a crime has occurred. They want to be impact-led. They want to focus their resources where they're going to have the most impact. They want to have, the right type of trained officers in the right type of situation doing the right time of work. They want to be outcomes driven, right? They want to be able to measure their performance and then change how they work based on how they're performing. But to be able to do all these things, you need to be data driven. You have to be data driven. You can't measure your performance if you don't have your data. You can't be proactive if you can't look in the data and detect what's happening. But, and what do the police really need? They need a unified, actionable view. They need a 360-degree of their data. They need it fast. And more importantly than most enterprises, they need it to be correct and they need it to be complete. Fast, correct, and complete. That's incredibly difficult to do all three with most technologies. But the reality for the police is that their data is in silos. Data is spread across tons of disconnected databases. In the case we're going to show you today, the force in Staffordshire had 10 different police databases that they might need to log into in any given time to put together information on a suspect or a victim. Data quality issues are incredibly significant. A lot of data is collected in command and control systems where you've got somebody yelling down the phone at a 999 operator, and that 99 operator is trying to type as fast as possible. So you have all sorts of incredible problems with name misspellings, address transpositions, things being stored in the wrong fields. There's all sorts of data quality problems. And data collection is a slow and very manual process. Taken on their own, each system siloed off, being able to use that task-based system, a 999 system or a crime recording system, taken on their own, that limitation doesn't seem so insurmountable. But when you put them all together and you're trying to do things in a fast-paced live intel environment, it becomes incredibly impossible. And the status quo often wins out. The current state looks something like this. Imagine you're a police intelligence officer or an analyst who is trying to put together a view of a potential terrorism suspect, right? You've got to pull together everything that the police know about this suspect. You need to do it very quickly because you need to help an officer with their investigation. So you log on to a site like this, but then you also need to log on to something like this, and you also need to log on to something like this. And then you also need to log on to something like this, right? It could take hours or days to pull together the information the police need about a suspect. And to compound matters, once an analyst has actually figured out from all of this what a picture of a person looks like, the way they have to share this information, because none of these systems are really good for sharing, is they copy and paste it into a Word document or an Excel spreadsheet, further compounding the siloization, right? These are intelligence products. This is hours and days of intelligence work that's now been put in a Word document that can sit in a file server and it can't be searched. Right? Can't even be searched in its original source. You've lost provenance, right? You don't know where this data has come from. If you're trying to put together a case and you don't have provenance, it's incredibly difficult. There are several other ways that we've seen in the marketplace where other IT companies try to solve them. They've fallen, there's 3 of them we'll go through. 2 of them are the traditional RDBMS solutions, relational solutions. The first is a federated search, and the second is a COTS product. A federated search, the object is to avoid the data integration mess, right? If you're going to have to move everything into a whole bunch of, one relational database, that's going to be painful. Let's slap a Google-like appliance that will just, do federated queries across it. What do you get? You get a Google search. Google's terrible, right? I mean, let's be honest. You don't want 300 results. You want one result. You're looking for a person, but what you end up with is a list of document results that you have to go through. You're not looking for documents, you're looking for intelligence, right? You've got a list of documents, and I don't know if you can see from the back, but I cherry-picked a name. That would be a good example, Nigel Brown. If you're searching for somebody named Nigel Brown, which is a fairly common British name, you might have a problem. Does this have a, laser pointer. Here you see caller Nigel stated he was followed by brown car into a state. You're going to get a ton of false positives. So you've got the false positive problem, and then in order to be able to get anything out of that document, the analyst is going to have to open it up. They're going to have to read through it. These are really, really messy documents. They're unstructured, and they're particularly poorly structured. They're going to have to read through all of this to figure out what information they need. And so this is a solution that we've seen at many police forces. Doesn't work particularly well. The analysts aren't particularly happy with it. There are some applications that allow you to build really complex queries, but these analysts are analysts. They're not query builders, and they're not comfortable or facile with the technology. They don't like it. The second and more prevalent one we see are the COTS off-the-shelf products. These products, they promise easy ETL, low costs. They tell the police, they say, come give us all your data. We're going to give you access to all of your data in one beautiful user interface. It's not going to look as terrible as those terminal screens I showed you. It's going to be gorgeous. It'll be all in one place. But the reality is, and I can't believe I'm the person who made up this statement, this idea, extract, transform, and lose. But they do often end up losing their data. The reality of COTS applications built on relational database, and COTS is commercial off-the-shelf software. These are shrink-wrap products that they'll go in and they'll provide a very good service for the force. They'll say, we'll move all of your crime reporting and all of your case management into one application. But the reality is that it's incredibly expensive and incredibly difficult to move data. ETL is an incredibly difficult process. And what we see in the majority of cases is that the documents, the content ends up not all getting in. So you have to make decisions about what you're going to keep and what you're going to lose. And for relational databases, that means generally your unstructured content, your narrative content. We were talking to folks last week at a police force where the only way they were able to get their narrative content into their COTS application was to transform it all to flat text files, which means that all of the structure of the document is lost, and they can't really search it very well. They were able to get it in, but that's the only way that they could actually get it in, storing it as blobs and text in a table. Now, unstructured content, you're saying, oh, that's fine, it's whatnot, but that's the narrative content. Those are all the things that the intelligence officer has written in your intelligence report. That's your arrest record, that's your crime incident information, that's the call log from your storm call. So it's great, you've got names and addresses and stuff, but you've lost everything else. So the ideal solution actually allows you to use all of your data. The ideal solution does more than just give you access to all of your data behind a single pane of glass. It actually helps to build relationships and helps you understand the context of all of your data. The ideal solution would use semantic linking to see relationships between people, places, objects, and events. In a police setting, that's incredibly important. It would extract context from the narrative rather than jettison it. And it would help by build a complete picture by exploiting all of the value in the data. Luckily, here's one I've made earlier. I'm going to talk to you about a project just like that we've built. What we're going to show you today, what we're going to talk about today in depth, is the police intelligence platform we built with Staffordshire Police. This is an operational data hub, like many of the operational data hub talks you'll see today. We followed that design pattern. What it is it's a single point of entry for the police for all of their intelligence and safeguarding data. 4 applications that were built on top of a single database that integrated 10 different databases from the police. This is an application that was actually built in 12 weeks of development. I would like everybody, the entire team that worked on this whole project, to raise your hand. That's it? You did not, sir. He bought the coffees. 3 of us. It counts. The coffees were great. It took 3 of us 12 weeks to build this, and I do not write code, so it really took 2 of us to build this, and I bought coffees too. We had significant data quality issues because, as I said, there are data quality issues. We were able to overcome them, and we had problems that nobody in the police could really tell us about how their data was connected, right? They didn't really even understand. So we had to figure out as we went how all of this data was connected. The first application we built is an all-purpose 360-degree person search. It will be used for the police, by the police for putting together a single picture of an inmate getting ready to release, or a suspect being investigated, or more importantly, an at-risk individual or child in a safeguarding situation. So instead of searching for Nigel Brown and getting a load of documents, I've searched for Liam Bridgewood, and I've gotten a list of Liam Bridgewoods. And when I open it up, I've got a single collapsed record of Liam. You can see here that I've got all of the different name spellings, that I've got date of birth, I've got address, I've got arrest records or crime records. But the magic here is using triples to find relationships. I don't know if it might be very hard to see, but we've got our suspect here, Liam Bridgewood. I should also point out that this is not real data. This is obviously mock data. They don't let us take that out of the police. Liam Bridgewood here is a suspect in a common assault and battery. He's also a suspect of harassment. The victim of both of those crimes is Sarah Polly. They don't live at the same address, which is good to know. He's also been mentioned in a child protection case. He's been involved in a bunch. In a matter of seconds, what we've been able to do is we've allowed the analyst or the officer to see very quickly a view of that person in their context. Right? It's a little bit different from the context that David Gorbett was talking about today, but it's very important for the police to be able to understand very quickly the context of a person, be they a suspect or a victim. Building on that, we built a second application where we were supporting those officers who were doing child sexual exploitation investigation, who often go to a victim's house and they are given permission by the family and by the usually teenage girl to take a copy of their Facebook archive to be able to be searched as part of an investigation. What those officers have to do now is they have to open up that Facebook archive. It's just a zip file full of flat HTML, and they have to read through it. Anybody here who's got a teenager knows they could be extraordinarily prolific on Facebook. I have over 500 friends. People who are friends with me on Facebook know I post like a teenager. Going through my Facebook archive would just be impossible, trying to find anything, trying to read through it. You know, it's a haystack. It's a needle in a haystack under a barn of hay. It's just impossible. And so what we did was we built an application where we could quickly ingest the Facebook archive, and we could unpack the data. And then we could use the semantics. Again, we're reusing the semantic search capability to find people on the friends list who we think we have information for in a police database. But we're also using MarkLogic's inbuilt search technology to search across those documents to find those chats that are suspicious. And in reality, we were actually able to reliably identify suspicious chats inside MarkLogic just using our search capability. But it's a really good example of using a combination of documents and triples inside the same database. The third application we built made use of our geospatial capability. This addresses more of the bread and butter of policing, but what they were doing is they're logging, the analysts at the force are logging in every day, and they're reading the 999 call logs to try to figure out if there's any crime that sounds familiar, something they've heard the last week or the week before, trying to manually detect of crime. So we flipped that on their head and said, well, what if you actually could just search across every crime, every call that happened in the last 24 hours, and so you could see on a geospatial and a temporal basis whether or not a crime is happening. So now they can just log in the morning. Instead of having somebody just looking at call records and trying to remember something, they've actually got a full snapshot of every crime incident that's happening. Our plans are to also be able to do things like layer ANPR, which is license plate. So there's ANPR systems that recognize license plates. So if you've got a group of people, stealing catalytic converters, which, believe it or not, is a pattern we saw, out of cars, you could see hotspots of where they occurred. If you could see that there was a known criminal with that MO and their car was detected in the same neighborhood, you've got a reasonable suspicion that they might be involved, helps you in the investigation. And the last application we built was to enable those analysts to be able to actually start to become really proactive. The last application is the least visually interesting one, and I've made it even better by having a gross screenshot. But basically what this is every few weeks, the analysts, when they have time, will troll through their systems trying to find at-risk children and adults. So what they're trying to do is this is very much a focus of the police. I don't know that everybody realizes how focused the police are on safeguarding in this country. What they're trying to do is they're trying to identify people who are likely to be harmed sometime in the future so that they can intervene early before anything really serious happens. They're trying to prevent anything terrible from happening to these people. But because they've got to log into 10 different systems, as you can imagine, it's virtually impossible to try to find these people. And also, the Peel report has criticized most of the police forces in that they cannot demonstrate that they are using the same methodology over and repeatedly because it's done by people, and people have confirmation bias and they misspell names, and there are all sorts of problems entailed. So the last application was about, could we, using semantics and the data, could we actually identify people who are exhibiting patterns of behavior that would class them as vulnerable so that the police could actually intervene early? And we were, oh wow, that's terrible. And we were able to do that. So it's 4 applications built on top of an operational data hub using a mixed model of semantics and documents. I'm going to hand over to John to do a technical deep dive of how we built it.
Thank you, Jen. So how did we go about doing this? We went about it the same way that we go about many MarkLogic projects. We start with the data. So we started with the data, exported source data from these underlying systems. It could be tabular data, it could be CSVs, it could be XML or JSON. We didn't care. But then we load it as is, utilizing the underlying MarkLogic data model, which is document orientated, so you can save it as XML or JSON. During the load process, we can also record provenance information. There's a fantastic ontology available, W3C Provo, and you can record information about where it came from and any alterations done to the information at that time. We then harmonize the data using the common envelope pattern, and then we extract data, we extract entities that conform to the pole model. The pole model is a way of modeling police data. It encapsulates 4 entities: people, objects, locations, and events. So utilizing those 4 entity types, you can categorize all police data. So when it came to extracting and harmonizing people, the first thing we do is generate a unique ID for each person entity instance. And that could be generated, or it could utilize an existing unique ID from the underlying system. We then harmonize the names and other data formats that have come from the data. The reason we do that is some systems might be using first name and last name to record forename and surname. So we harmonize it into standard elements that can then be queried. We also do the same with dates. Dates can be in different formats. We harmonize that data into a standard date format that can then be consistently searched across the system. At the same time, we also generate phonetic versions of the names. So MarkLogic has a built-in function, double metaphone 2. This allows you to take any name and turn it into a phonetic representation. Because the data quality is so variable and in some cases so bad, using the phonetic versions allows you to search and also account for common misspellings of names. For events, we do the same, generate unique IDs to represent each event, and also similarly harmonize the data formats. Now, the great thing about MarkLogic being schema agnostic is you don't need to define that entire model up front. You don't need to harmonize every single element. You only need to harmonize the data that you're going to be using for the application that you're trying to build. And then you can do that work iteratively. For locations, we were able to make use of a reference data source. So Ordnance Survey, the UK mapping agency, they have a product called Address-Based Premium. This is a master data, reference data source of all addresses within the UK. And this Address-Based Premium includes an item called the Unique Property Reference Number. So this is a unique identifier that identifies every single property within the United Kingdom. So by using this information, you don't have to rely on addresses which are often misspelt, which might often be incorrect. Postcodes can be incorrect. Addresses can be, you can use street or the abbreviation ST. It helps eliminate those common data problems. And then what we do is calculate hashes. So we compute hash codes for every unique dimension combination to disambiguate the entity. That is the combination of fields that uniquely represent that entity. The approach you take here is highly variable on your input data. It depends on the data quality. We found, working with the data set that we had and talking to the subject matter experts, that utilizing a combination of first name, last name and date of birth, and first name, last name and address was the best approach for that underlying data. It helped disambiguate the entities without creating false positives. We then record those. We record those hashes in MarkLogic, and utilizing the universal index, MarkLogic is able to resolve those keys. Because MarkLogic is a multi-model database, we can start storing relationships between those entities as triples. So here we're storing the relationship between a person and an event, person and a crime, where that person is a suspect in that particular crime. Now we also record the relationship between the entity instance, i.e. the person, and that disambiguation hash code that we generated previously. And the reason we do that will become much clearer on the next slide. So what we are doing is using these hash codes and MarkLogic's semantic capabilities to collapse these entities at query time. So if we have a person A, and they are the same as the hash code that has been generated, the dimensional combination of field names that uniquely identifies them, and person B similarly has that hash code, then we can infer that person A is the same as person B. We can do the same for other hash code combinations. Person A is the same as person C. They are the same, but because of the transitive relationship, person C is the same as person B. And so on. So we can do this for many different entities, duplicate entities within the system. For the data set that we had, the most prolific offender had 183 different unique records that we were able to collapse into a single 360-degree view.
That was only a 2-year period of his life.
So what are the advantages of this approach? The first advantage is it's extremely fast. Because we're limiting joins, we're modeling the entities as documents, denormalized, and then use triples to store the relationships. It's really efficient and quick to query across it utilizing MarkLogic's universal index. It's also really fast to load data. So the bulk of the disambiguation effort is happening at query time, so ingest performance isn't adversely affected. And the disambiguation process, the collapsing the entities into a single 360-degree view, is really fast. We make use of a built-in function, sem transitive closure, really efficient, able to disambiguate hundreds of entities and still achieve sub-second performance. It's also flexible. So because we're doing the disambiguation at query time, it allows the rules to be changed on a per-user basis. It also reflects role-based access controls as well. And you have the ability using different predicates, maybe not same as, maybe similar to, which represents a different degree of confidence that two entities are the same, can be used for different use cases where that same degree of confidence is not required, and some false positives might be accepted. Now, organizations recognize the value of a multi-model database, and there's a few ways that they'll go about building one. And a common approach is this, a multi-product, multi-database stack. So combining multiple database technologies, a relational or non-relational database, a search engine, and also a graph store or a triple store. Now, in order to combine those, you need to then develop bespoke middleware to do the integration, because you've got none of that out of the box. So you need to synchronize ingesting data across 3 or more different systems. Because some of those database technologies might not be ACID compliant, you need to write your own transaction handler to ensure consistency across those databases. Because there is no way of searching across those separate databases in a single unified way, you have to pull the data in memory into the middleware. So you need to unmarshal and marshal the data. You're doing in-memory joins, which are extremely expensive and extremely slow. And because you've implemented this system in middleware, you need to add security controls within that code. So you're writing your own security access layer. And as soon as you go down that path, you're introducing the risk of vulnerabilities and bugs and possible intrusion into your system. So Jen, I think we've got a better approach that you would like to talk about.
Yeah. So unlike the multi-database hybrid that you got, the applications that we've built and everything we've talked about today were built with a single set of technologies. I had an interesting conversation with James this morning about what kind of connectors and things and whatnot we knew. And to be fair, we didn't use anything. The application that we built is a single instance of MarkLogic, and we've got an Angular JavaScript front end sitting on top of it. That's it. We're able to integrate data from multiple sources, provide the security, the enhanced security, provide search, semantics, transaction alerting, and flexibility all within a single database. And what this capability will allow police forces to do is to only have to invest once in their infrastructure. And then they've got something that's not brittle, something that doesn't take lots of code to maintain, and they'll be able to focus their energy on building up new applications, new security products that they need for their team. So the benefits of a document or triple store, if they're not already clear, all the benefits of all of the different types of databases you've seen before, right? You've got your triples, you've got your documents, but all of the benefits in a single database, in a single schema-agnostic database, also means that you can begin developing right at the beginning of your project. Things are faster, things are more secure, things are more tightly integrated. We've got simplicity of a single platform. People ask me a lot as an architect, what's my approach and my focus to architecture? And sometimes I think software architects are paid by the number of boxes on a page, right? You've all seen them, right? How many boxes can I put on this page? And most of the time when I end up, some folks in here would have been in a requirements workshop with me, when I draw an architecture for MarkLogic, it looks like this. It looks like this, right? It's just a box. It's one box. You just get paid by the one box. Keep it simple. And that's the key towards being able to deliver, to be able to continue to deliver, and also not to end up with something that you then need to rewrite in a few years. So why MarkLogic in summary, and then we'll take some questions. Let's see if I can see my notes. There were some takeaways I wanted. The right solution enables all data to be leveraged, right? Relationships within the data are as important, if not more important, than the data itself. So it's not just about having access to all of your data in one place. The benefit of a multi-model documents and triples is that you can find the relationships between your data. And to be honest, that's what most customers, police and otherwise, are really interested in. Not just how many things do I have in my database, but really what's the relationship between that data and that database. And the total cost of ownership is lower when you're only having that single box on a page, when you're not having to maintain multiple separate architectures, when you're not having to build a custom middleware layer, when you're not having to write security in the application. And with that, I'll turn it over to any questions if there are any.
One of the biggest challenges is to ensure first the provenance of the data, which you've touched on, but also those hash links that you created on people, person entities. Now, that's an incredible challenge across a large data set. I guess you had a couple of years' worth of staff's data. So how did you confirm that one individual was the other individual and so on? And you mentioned some guy with a lot of aliases or nicknames.
So we worked,
is that manual or is that
it was initially manual. It had to be manual. This is something that's complex enough that you can't really necessarily automate it right out from the box. This was a pilot program as well. It was a smaller program. So we worked very closely with the analysts who actually, what they did prior to, or while we were doing development, is they went through and they found a whole bunch of test cases, and we worked on those test cases. When we moved into production, we'll automate those based on those test cases. Folks that we really know have incredibly complex. So we'll do that with testing, automated integration and unit testing. But it didn't actually prove to be, we were actually quite surprised at how well we were able to make those links. The other thing we did is we were incredibly conservative about how we decided a person was an entity. We erred on the side that if we couldn't be absolutely 100% sure with some pretty specific data points that these two objects in the databases represented the same person, then we did not collapse them, because the police do not want to. They would rather end up having to kind of manually make those merges than run the risk of having an innocent person mixed up with a criminal. So we're very conservative about how we do the matching.
Just to add to that, so the way that we match the entities together is by storing a triple to say that they're the same as. So we're not actually merging the underlying data. Yeah. The underlying data is still there. So if you need to unmerge a record, it's not a complicated process. You simply sever the link because you're keeping the underlying data.
So if you've got the hash links, and you give an example of multiples, are they also linked? So hash 1 is the same as hash 2?
That's correct.
And
yeah.
you can link, so identifying John Smith or whatever your case was, you instantly see, oh yeah, that's the one and the same person.
Yeah.
Yeah. So the particular combinations we used were first name, last name, date of birth, first name, last name, address. And that was an extremely conservative way of identifying unique entities. We saw duplicate entities, but we saw those duplicate entities where, for example, information was missing. Because there was no date of birth, because we were erring on the side of caution, you search for the name, you would have a record with 183 people collapsed into one, and then one where their information had no date of birth. So one of the features that we would add in the live application is to allow users of a particular role level and privilege level is to manually mark them as the same. But as I said before, because you're marking them to be the same, it's very easy to sever that link afterwards. You're not actually combining the data. That combination happens at query time.
Was there another question? Oh.
Yeah, so you said you've merged 10 different database systems into one. Is the plan to eventually do away with those guys and have the hub be the data of record, or are they going to continue to feed
some
in?
of those systems are legacy systems that will be decommissioned or will be rewritten. A lot of those systems are still incredibly useful for what they are. A command and control system for a 999 operator does that very well. And there's be no point for, it'll kill me, there'd be no point to rebuild that if it's working. So I think the intention of this is some of those systems will be retired if they're no longer used. We have some police forces that have archives that they can't search. They'll be merged in and then they can be decommissioned. But no, a lot of those systems will be kept. And the nice thing is they can be decoupled. So if you're just dumping data in, you've got your live system kind of working here. It's creaky, it's old, it's on a green screen. You're building your new one over here. You're dumping your data in. When you go to do your data migration into the new application and start that, it's really quite simple.
And so sort of follow up to that is for the future, as you build new things, does this data hub existing with all the nice relationships help you build better apps down the line and perhaps even conceptualize things that weren't possible before?
Absolutely. Absolutely. I mean, I think what's really great to see is as we've been working with more and more police forces, they're starting to come up with some incredible ideas for things to do with this data that we hadn't even really thought about. One of the things that we're finding also is, for example, police are really interested in doing performance-related analysis. And how do you do performance-related analysis on, performance analysis for the police is, a crime was reported on the 1st of June. By the 15th of June, it was solved. By the 30th of June, the case was done, right? You need all those pieces of it's very hard for them to do that right now. So we're finding all sorts of use cases that the police can use just off this single integrated data set. It's a real game changer for these types of data sets. I mean, the police and intelligence agencies, they collect a tremendous amount of data, and we're always asking, why didn't that thing get stopped? Why didn't they know? And it's because they don't have the data in one place to see that picture. So yeah, it's been very interesting. I mean, I think we're looking at we're starting to look at things like evidence. So like holding metadata about what evidence the police hold. There's all sorts of interesting use cases that our customers are coming up with actually as well.
The key thing here is it's an enabler to innovation. So you've got all the data in one place. You've done the disambiguation. That's reusable. That's done. And then you can start innovating and building new applications on top that leverage that same bit of data. It's all running off the same platform. So Jen mentioned performance analysis. Demand analysis is another interesting topic that you can do much more effectively once you've got all the data in one place.
I know it's lunchtime. I know you're all starving, but anybody else? Yeah?
Non-technical question, just a
Go for it.
customer results, basically, like how many extra arrests are made, and the final result for the customer.
This is not yet a production application. This is a partner. This is the first phase of an application. We're currently working with a few police forces to turn this into a production application. But I anticipate that there will be many, many more arrests. Sorry, I'm looking. I've got somebody in the front row. So.
I will just add the social media profiling application that Jen showed, where you drop a Facebook archive and analyze it for suspicious chats and potential links within that police system. We were given some real Facebook archives. We dropped it in the system, and we actually found a previously unidentified link with a known individual who had priors for child sexual exploitation. So as a result of that of surfacing that link, this crime is being reinvestigated.
And Jennifer's telling us we have 0 minutes left. Okay. Thanks, everyone.
Thank you.
Oh, sorry.
So if you do have any questions, you can find Jen, John, Imran, or Barry. You can come up to me or whoever's got a MarkLogic badge, and we'll make those introductions. Feedback's really important to us, so if you don't mind providing that through the application, that's much appreciated. Thank you very much.